What's up, calculus students? Mr. Messer coming at you, trying to update this video over the course of today so I can see you tomorrow. And you're all ready to go. We're doing antiderivatives. We are backwards taking derivatives. Now, first things first, and what we will do in the future mostly is we will take an f prime and turn it into an f. But if I say take the antiderivative of f, you're going to give me big F. This process of going backwards is called taking an antiderivative. The key to antiderivatives is knowing derivatives. Okay? You can figure out some of the rules for antiderivatives by just knowing derivatives. The power rule being the first one. If my derivative needs to be x to the fifth, I need to start with one more in the power, but knowing that this power comes down first with derivatives, the 6 will come down first. I need to kind of undo that 6. I will need a 1/6. This is the power rule for antiderivatives, is to add 1 to the power and then to multiply by the reciprocal or to divide by the new power in that order. So that's the antiderivative of x to the fifth. X to the fourth would be x to the fifth divided by 5 or times 1/5. X cubed would be x to the fourth divided by 4 or times 1/4. X squared would be x cubed divided by 3 or times 1/3. X would be x squared divided by 2 or times a half. And then this key one. 1. The antiderivative of 1 is not 0. You're so used to taking a derivative of 1 and it being 0 and things disappear on you. But the antiderivative of 1 is x. Now, what does disappear on you when you take derivatives? Derivatives of numbers are 0, which is the key concept when taking an antiderivative, that you can have any number for this big F, and it would be correct. If you had 5 here, well, the derivative of 5 is 0. If you had 1 here, the derivative of 1 is 0. Any number would work here. And so this is one thing that has to be done. You might forget about it often. But there will be problems soon in this homework where if you do forget about it, you're going to be wrong because it just won't work out. There is some number that could be 0 or could be something else. We'll call it a constant c, okay? And that number can be added to this function. We don't need a bunch of plus c's. We just need one plus c. Think about this function. If you take the derivative of this function, you get this, no matter what this number is. All right, to show you the steps if we have coefficients. First thing is these coefficients, they're not x's, so it's not x's times x's. So you're not going to take the antiderivative of the 5. You can just figure out, oh, I need x to the fifth. Now, most of you will just be able to be oh yeah, that's x to the fifth. But for ones that are more complicated, like the next one, it might be beneficial to take this a step at a time, where it's okay, leave the 5, it's not bothering you. Take the antiderivative of x to the fourth. Add 1 multiplied by the reciprocal, or divide by. Okay, 5 divided by 5, or 5 times 1/5 is 1. Leave the 4. Add 1 multiplied by the reciprocal. 4 times a fourth is 1. Leave the 3. Add 1 multiplied by the reciprocal, or divide by. All right. Leave the 2, add 1, multiply by the reciprocal. Boom. Power rule works for fractional powers. I don't know if we did many of these in class, but it works. Probably the best thing to do, and for now, what we always want to do is rewrite powers so that they are in the numerator, no matter if they're fractions or negatives. And sometimes we'll have to simplify. So we got this. Now, if I were to take the antiderivative of this, use the rule, keep it simple, leave the 2. Don't try to figure this out by yourself. It might be too complicated. Add 1, multiply by the reciprocal. Okay, or divide by 3/2, multiply by 2/3. That becomes 4 thirds x to the 3/2, or 4/3 square root of x cubed, which we don't need, but we know that it's equivalent to. Here, leave the 3, add 1. What does adding 1 look like? It's not 2/3, it's adding 3/3. So you get 4/3. Multiply by the reciprocal, you get 9/4. This is not something that's easily figured out, so this is where the rule comes into play. Add 3/3, we get 5/3. Multiply by the reciprocal, leave the 4. You get 3/5, you get 12/5, x to the 5/3. Add a constant c. Not super important now, but you got to know it could be there. But when we start to find specific function values that are missing or specific functions in the future in this homework, we'll need to take care of that. Now, trig functions. Remember derivatives. If I said, take the derivative of 3 cos x, would you use the power rule for x? Would you say it's like -3 sine 1? No. You'd say the derivative of 3 cosine x is -3 sine x. Would you take this 3 and take the derivative of the 3? No. You don't use power rules for numbers times x's. You use power rule for x's times x's. These are very important. Everybody thinks it's more complicated going backwards, and sometimes it is, but sometimes it's not. You have to remember your derivatives. The derivative of cosine is negative sine. Okay. The 3, leave it. Negative cosine's derivative is positive sine, so the antiderivative of sine is negative cosine. That's the first one. There's no adding 1, multiplying by reciprocal, because it's not a power function. It's just a trig function, and you remember trigonometry. 2, cosine. Leave the 2. The derivative of sine is cosine, so the antiderivative of cosine is sine. It's not something you memorize. You just keep the derivatives in your head. If you have stuff in the bottom, you're going to rewrite using negative powers. You're not allowed to use the power rule in a denominator. Also, remember how you can rewrite things. Like, don't worry about this 2. Write it as 2 times x to the -3rd. It's good. The power rule for antiderivatives works. If there's any constants, just leave them. Add 1, multiply by the reciprocal. Okay, multiplying by the reciprocal of -1 is just -1. We're good. Leave the 2, add 1, multiply by the reciprocal. -2's reciprocal is -1/2. Good. Leave the 3, add 1. Make sure you go in the right direction when you're adding. Multiply by the reciprocal. What happens? I get -1 over x minus 1 over x squared minus 1 over x cubed. 3 and the 1/3, the 2 and 1/2 cancel. Now for the next ones, what if it's 3x squared? This is so important. So many students make an error on this. If I have 2 over 3x, the 3 is not taken to the first power. You could rewrite this as 2/3 times 1 over x, or more importantly, rewrite it as 2/3 times x to the -1st. We see this a lot with students with like x over 3. They don't know what to do with it. It's like x over 3 is the same as 1/3 x. I probably should have put a couple of those in here, but I didn't. We'll be fine. Okay, so 2 over 3x is 2/3 times x to the -1. X over 3 is 1/3 times x. We have to end this video soon, or at least pause. So, starting with rewriting, keep the 2/3, move the x's. Keep the 3/4, move the x's. Keep the 5/6, move the x's. Take antiderivatives using the power rule. Leave the constant. Don't worry about the antiderivative constant. Add 1 to the power, multiply by the reciprocal. Combine things. And maybe move the x's back down. Keep the constant, add 1, multiply by the reciprocal. Keep the constant, add 1, multiply by the reciprocal. Don't forget a plus c, so that you know you could have some number here, and when you take the derivative number, it goes away. All right. For the rest of this page, the key is you don't know chain rules. You don't know product rules. You don't know quotient rules. So you're going to have to simplify. First, turn products into sums. Distribute things. Multiply things out. And understand that this symbol is a new symbol. It's a skinny s. It's tall. We call it an integral. You need to be able to call it an integral. Don't say it's a skinny s. It's an integral. For right now, the integral means you're taking the antiderivative. It is the opposite notation of d over dx. It's like, take the antiderivative of whatever's in the parentheses with respect to x. It's not times dx. I mean, it is times dx, but it's like the dx you're just going to think of as with respect to x. Very similar to d over dx means take the derivative with respect to x. The integral means take the antiderivative, and the dx means with respect to x. And I'll do that during lunch. All right. Where am I? Disappeared. Okay, so simplify first, but don't forget, after you simplify, you still have to take the antiderivative. We distributed, but now we have to take the antiderivative. I should do this in the correct order. Add 1, then divide or multiply by the reciprocal. Leave the constant, add 1, multiply by the reciprocal or divide. Don't forget your plus c, or else you're going to get things wrong in the future. Okay? We've simplified, but don't forget to take the antiderivative. Integral is the notation for take the antiderivative. Add 1, multiply by the reciprocal, leave the constant, combine. Leave the constant, add 1, multiply by the reciprocal, combine. 9's antiderivative is 9x. Don't forget you could have a constant. I'm going to tell you, like, the next couple are, like, trickier. And honestly, if you don't do this one or don't do this one, it's fine. If you just do these, that's better. On this next page, these are kind of tricky. These are important. Make sure we spend plenty of time on the solve differential equations part. So I'm going to breeze through these. This one being important, this one not so much. How do we simplify this? It's something that has shown up in the past. Well, how do you simplify x squared times x cubed? You add the exponents. If it's x to the 1/2 times x squared, if it's x to the 1/2 times 2x, what do? Add the exponents. That's not 2.5. That's 4/2 plus 1/2, which is 5/2. It's not 1.5. I mean, it is 1.5 actually. It's 2/2 plus 1/2, which is 3/2. This is simplified. Don't forget to take the antiderivative. Add 1, leave any constants, divide or multiply by the reciprocal. Leave the constant, add 1, multiply by the reciprocal, combine. 4/5. Same thing here. What's x to the 1/3 times x squared? What's 2x times x to the 1/3? Well, you add. This is 6/3. This is 3/3. That means this is x to the 7/3. This is x to the 4/3. You've simplified. Now take the antiderivative. No constants, so just add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal, combine the constant. 6/7. I'm not going to do it. This one, when we divide, what happens when we divide? We subtract. I'm dividing both of these terms by x. If you want to, you can rewrite this as x cubed over x plus x squared over x. Because if you combine these two fractions, you get that, because you have a common denominator. If you're dividing by one thing, you can rewrite. If you're dividing by more than one thing, it's not this easy. Then you get x squared and x. Power rule. Don't forget to take the antiderivative. The antiderivative of x is not 1. Got to add 1. Multiply by the reciprocal. Keep derivatives in your brain. I'm going to skip the next one, but it's the same deal. 6/3 minus 1/3 is, I'll do it. Gosh darn it. It's not 6/3. It's 9/3 minus 1/3, which is 8/3. This is 6/3. Okay, that's how you'd rewrite, and then you would subtract to get 5/3. Add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal. Don't try to do anything fancy. But you got to remember your derivatives. You got to remember the derivative of secant is secant x tangent x. You're not going to try to undo this using the product rule. You're not going to try to add 1. Again, derivatives of trig functions are just other trig functions. I don't want you to worry about this one. I'm not going to do it. This one, I do want you to worry about it. You should know that this is the same as cosecant squared. It's reciprocal of sine squared. But again, you just have to remember your derivatives. The derivative of cotangent is negative cosecant squared. So the derivative of negative cotangent is negative cosecant squared. I don't want to do this one. You got to remember your trig derivatives. Let's just go through them. Secant's derivative is secant tangent. If you see secant tangent, it's antiderivative of secant. Cosecant's derivative is negative cosecant cotangent. If you see negative cosecant cotangent, it's antiderivative of cosecant. Okay? Tangent's derivative is secant squared. If you see secant squared, it's antiderivative of tangent. Cotangent's derivative is negative cosecant squared. On your test, you're probably going to have one of these. You're not going to have any of them on the quiz. All right, to the important questions. The differential equations. This is where the whole plus the thing matters. Why do we have C? Here's the situation. I'm giving you F prime. I'm giving you a point on F. And let's say I ask you for another point on F. What's F of 1? Okay. Or I ask you to solve the differential equation. Solving the differential equation is finding F. Don't. Because
I just interrupted the whole video.
If a kid is shown, that's where I could get in trouble.
It's YouTube.
You know?
It's been posted too.
Yeah, thanks. I'll call you out by name. But I won't show you. Solving the differential equation is taking the antiderivative, finding the equation for f. So, key step to this is to take the antiderivative. Again, leave the constant, add 1, multiply by the reciprocal, combine, don't forget your plus c, y. Because c can be found with this extra piece of information. You're told f of 1 equals 6, f of negative 1 equals 6. Well, that means this point, this function, has the point negative 1, 6. If you plug in negative 1, your output better be 6. I'll have 3 minus 2 plus c better equal 6. All right, well, that means c has to be 5. Here is what we call our specific function f of x. The actual function f of x, whose derivative is 12x cubed plus 2, and who has the point negative 1, 6, is 3x to the fourth plus 2x plus 5. Okay? This is what we call the solution to the differential equation, or the original function, the specific original function. But the extra step is to plug in 1 if I ask you to. All your quiz questions, I'm going to ask you for a function value. You plug in 1, you get 5 plus 5, you get 10. That's your answer that I would ask you for. When does this class actually start? 45, right? All right. Cool. Here's another situation. I'm giving you the equation for f prime. I'm giving you a point on f. Let's say I ask you to find f of 1. Well, why do we need c? If I forgot about c, then this statement would be false. If I plug in 2 into this equation, I get 8 minus 4, which is 4. That's not correct. F of 2 equals 3. I'm told that. This is why you have to have a plus c. This is why this point will help you find c. C equals negative 1. Now you have a specific function that has the specific point, that has this specific derivative. X cubed minus x squared minus 1. And now if I ask you to find f of 1, you got 1 minus 1 minus 1, you get minus 1. That's it. I'll finish the rest of this after school today. Hey, keeping it going. Finding C, important if you're given information. This is the question that was perfectly asked. Here, I'm f prime. I'm given f of 0 is negative 1. What's f of 2? So we have to take the antiderivative to go from f prime to f, which is the primary thing of what we're doing. It's usually not f to big F. It's usually we're going to be given f prime. We need to go to f. It kind of makes sense. Now we're doing that. Leave the constant, multiply by the reciprocal, incorporate the constant. Don't forget your plus c, or else things are going to be wrong. I'm told f of 0 is negative 1. C's got to be a very specific number then. So 2x minus 2x cubed plus c. If I plug in 0, that's 0, that's 0, that's c. That has to equal negative 1. Okay, I got c. So this is what's called a specific f of x, a specific solution to my differential equation, a differential equation being like an f prime equation. Solving it meaning go backwards, find what f is. F of 2, 4 minus 16 minus 1. It's minus 13. Okay. Go backwards. Add 1, multiply by the reciprocal, incorporate the coefficient. Eventually you'll be able to do this all at once, but you're not there yet. So just like two-step this. negative 6x squared plus c. I am told f of 1 is 4. This is where it's like, yo, got to include the c because you don't know the specific function that we're talking about. But now we have this information provided. And now we have the specific f of x. And what's f of 2? Negative 24 plus 10 is negative 14. What if I give you f double prime? Here's the key. We talked about it in the lesson, unless you were in my third period class where we didn't talk about any of these, but like I told you, heads up, you're going to have to find c. Every step you go backwards, you need a c. You need it. This is wrong. Sorry about that. This should be just f of 1. So you have a c. Now you're asked, hey, f of 1, or you're told f of 1 equals 2. F prime of 1 equals 2. That means when I plug in 1, I better get 2. Oh, look at that. C is 0. That's a bad question. You might have gotten lucky if you didn't include a c. That means, yeah, bad question. If you go backwards, again, you get x squared plus c. Again, bad question because I said this f double prime of 1 is 3, but hopefully you're watching this video. F of 1 equals 3. This c has to equal 2. So my original function f of x is x squared plus 2. I probably would ask you, like, what's f of 2? F of 2 is 4. You're definitely going to be asked that on your quiz. That way we don't have to grade things. Like, you're going to be asked, like, what is... I think there's, like, 3 questions where you're finding f of a value and 1 question where you're finding the equation f of x. This would be, like, a question that I would say, what's f of x? Okay, go backwards once. 4's antiderivative is 4x. Cosine's derivative is negative sine. Negative sine's antiderivative is cosine. Include a plus c. Every step along the way, you need a plus c. If you plug in 0, careful, the cosine of 0 is 1. Therefore, c, this first c has to be 1. If I go back again, I need to take the antiderivative of 4x. X squared times a half times 4 is 2. The derivative of sine is cosine. The antiderivative of 1 is x. X's derivative is 1 plus c. F of 0 is 5. C is 5. This is considered the solution to the differential equation, which you kind of think of as the specific equation whose information checks out and whose derivative checks out. I don't love this question, but it's a good example of what you might see on your test. You need to know tangent's derivative secant squared. You don't try to finagle secant squared and use the power or anything. If you see a trig function, you just got to be thinking, which trig function's derivative is that? Don't forget a plus c. That's f, sorry. F of pi over 4 is the tangent of pi over 4. Is 10. Tangent of pi over 4 is 1. And finishing off is a great question. Here's f double prime. F has a horizontal tangent at 2, 1. Okay, so 2, 1 is a point. What does it mean to be a horizontal tangent? Think about that for a second. A horizontal tangent. The slope is 0. F prime of 2 must be 0. There's the 2 pieces of information. You go from f double prime to f prime. you get x squared plus c. F prime of 2 has to equal 0. C has to equal negative 4. So f prime is x squared minus 4. Go back another step. F 1/3 x cubed minus 4x plus c. F of 2 is 8/3 minus 8 plus c. That has to equal 1. 8/3 minus 24/3 is negative 16/3 plus c equals 1. 3/3 plus 16/3 is 13/3. So c is 13/3. So f of x equals 1/3 x cubed minus 4x plus 13/3. No. 16/3 plus 3/3 is 19/3. Add 16/3. That's it. Messner out. Later.